There's a whole branch of mathematics called combinatorics, and all it is counting the number of different ways that you can do things. And you'd think, like, why would anybody study that? It's got tons and tons of applications and cybersecurity and stuff, especially right now. Is what a lot of it is. But in order to do probability, we have to count, because you guys know how probability works. You've been doing it all year, right? We make a fraction, and we put the total number of things on the bottom. Is it frozen? I'm sorry. Probability, we make a fraction, we put the total number of things on the bottom. And then the number of positive things, the number of things we want on the top. Right, so remember back in chapter 1 when we were doing probability, and I said you got a bag of shapes that's got 3 different types of triangles, 4 different quadrilaterals, and what's the probability if you reach in and pull one out randomly that it'll have 2 sides of the finger? Remember all those types of problems? And you just had to know this was always how many shapes were in the bag, and then the hard part was counting up how many of those shapes have that particular property, right? So it turns out that most probability stuff is actually not that difficult. It's the counting part that gets tricky. So I want to talk about, for probability, I want to talk about counting. And I'm going to give you the classic combinatorics problem. The classic counting problem involves building an outfit. Have you seen this before? So let's say you go on a vacation. Let's say you're traveling over the holidays and you take a suitcase with you. You don't have your whole closet full of clothes in there, but let's say you've got some of your stuff. Okay, maybe you did some shopping before your trip and you're going to take some of your new stuff. So let's say that we've got 5 different tops that we bring on our vacation. And we've got how many bottoms? 3 bottoms. Maybe like a pair of jeans and some shorts and some hiking pants. I don't know. And 2 pairs of footwear, 2 pairs of shoes. How many different outfits can you make out of those options? And we're going to ignore fashion here. So everything goes with everything else. Nothing clashes. How many different outfits can you make? Anybody know? You can't miss. No, you wear one pair or the other. The answer is, I've heard a couple of people say it. The answer is 30. How are you coming up with 30? 5 times 3 times 2. So it turns out when you are making multiple decisions and you have different options for each of those decisions, if you want to know your total number of ways, you multiply the number of options for each decision. So I'm going to decide on my top, and I've got 5 to choose from. I'll multiply that by, so my decision for my bottoms, I've got 3 to choose from. My decision for my shoes, I've got 2 to choose from. And when I multiply all those numbers together, I'm going to end up with, we got 5 times 3 is 15, times 2 is 30. 30 total options. Outfits. 30 total outfits. So that's the big rule, is you multiply the number of options for each decision. So we're going to talk about decisions. And sometimes it's not truly a decision. Like when you toss a coin in the air, you're not really making a decision whether it comes up heads or tails. Like randomness is making that decision, right? But we can still think of it as a decision. It's going to come up one way or the other, so that would be 2. This came up in a previous class. What happens if you had an option? Let's say you were going to a beach and it was possible for you to not wear shoes. How would that change your total number of outfits? what would change here? If we had the option to not wear shoes at all, we could wear shoes if we wanted to, or we could not wear shoes. How's that going to change our? It would be the same. Would add more? What do you think, Zoe? One more option for pairs of shoes? I'm gonna say, can you explain why? Oh, yeah. You got 3 options for your shoe. Yes, good. And that's the key. It's not how many things you have, it's the number of options you have. So our options are the red pair or the blue pair or barefoot, right? So there would now be 3 options. So if that was a possibility, then we would no longer have 30 different outfits. We would have 45 different outfits. So sometimes it gets tricky figuring out like how many options do I have. Okay. All right, you guys feeling all right so far? All right. So let's go back to probability. So I'm going to talk about some random events now. So we're going to talk about, let's say we're going to roll 2 dice. And we're going to talk about some probabilities that certain things happen when we roll 2 dice. And when we do those probabilities, we know we're going to need a number on the bottom of our fraction. That number is going to be how many different ways can I roll 2 dice? So let's talk about how many ways. Oh, good question. These are 6-sided dice. 6-sided dice. So how many different ways could we roll 2 dice? So we would think of this like a decision. Now, it's not really choosing when I roll a dice, but I'm going to roll one and then I'm going to roll the other. So I'm thinking of that as 2 decisions. Okay, so there's 2 decisions for how this is going to come out. One for the first die, one for the second die. How many different options do I have for that first die? 6. It's a 6-sided die. And how many for the second die? Also 6. So the total number of ways altogether would actually be 36. So there's 36 combinations for how you can roll 2 dice. All right. So let's do some probabilities. What would be the probability that I rolled 2 2s? What number is going to go on the bottom of that fraction? 36. That's how many different ways I can roll 2 dice. Of those 36, well, feel free to move anything. Of those 36, how many of those ways has a 2 on the first dice and a 2 on the second dice? I'd say there's only 1, right? In fact, if we wanted to work it out, we could use the same idea. I've got my first die and my second die. How many options do I have for my first die if I have to roll a 2? 1. How many options for the second one if I have to roll a 2? Also 1. 1 times 1 is 1. So 1 out of 36 that you're going to roll 2 2. Here's a fun one. You're going to need to think a little bit on this. What's the probability that you roll 2 numbers that add to 7? I don't know any mathematical tricks for these. I would just have to think about it and count them up. I want you guys to think about it. You don't have any paper or what? Grab some up. Here. There's paper over there. Come on. Paper over there. Let's see. So I got my 2 dice. So it would be 1, 6. I'm coming up with 6. Did you get 6? 6 out of 36? Did you come up with something different? You're saying that these are the same?
Yeah.
But there's 2 different die, so I would say they would be different. Like if I rolled one and then I rolled the other, there's the first and then the second. Now you bring up a good point. So the question is, should we count these, or should we count all 6 of these combinations, or should these 2 go, like for example, these 2 are basically the same. It's a 3 or 4, a 4 and a 3. Should we count those as separate, or should they be the same thing? And that does come up. And when you get into algebra 2, you'll learn a difference between a combination and a permutation. And how does it work? I always have to think back. One of them, the order matters, and the other one, it doesn't. So let's stick with the version where the order matters because it makes things a little bit simpler. So I'm counting up 6 different ways we could do that. That would be 6 over 36, which reduces to 1/6. All right. Okay so far? All right, now we're gonna do something that I've not tried before, but we're gonna give it a shot. We're gonna do it slightly different way. I'm gonna write some rules, and I think I'll put them up on the whiteboard here. Yeah, I'll put them here so we can have it on the screen. All right, we're gonna play a game. You guys know rock, paper, scissors, right? Yes? You guys have played that before? Okay. We're going to play 3-player rock, paper, scissors. Okay, we're going to have a player A, player B, and a player C. And I'm actually going to get 3 people to come up here and play in a second. But let me tell you the rules first. All right, so, and these rules are set out in the book. If anybody's interested, this is in 4.2.3. All right, so player A gets a point if all 3 players match. Can you imagine how that would happen? So you go rock, paper, scissors, shoot. And if everybody does paper, or if everybody does scissors, or everybody does rock, then A gets the point for that round. We're going to do several rounds here in a second. Player B gets a point if 2 match. And exactly 2. All right, so no more than 2, no less than 2. And player C gets a point if what? If nobody matches. All are different. Well, I want you to think about this for a second. Is this a fair game? Is my first question. Is it a fair game? No? If you got to choose which player you were going to be, and you think it's not a fair game, what would you choose if you're trying to win? Which one do you think is going to be an unfair advantage? Who do you think? You think B is going to get an unfair advantage? B and C? Okay. All right. All right. I want you guys to give me some percentages. Now, someone's got to win, right? It's got to be one of those 3. There is no such thing as a draw. So our percentages need to add up to 100. So if you think B is more, like how much more? Do you think it's going to be like 80 and 10 and 10? You think it's going to be like 40 and 30 and 30? You think 50 for B? And then A and C would have to add up to 50 also. So we'll go with 50. Go ahead and finish yours, and then we'll come out. We'll let you make a guess too. What do you think? 50 and what? People seem to think that this was going to win more than this. Do you want to go 30 and 20? All right. Give me another guess. 20 for A and then 40 and 40 for these ones. Anybody have any other guesses? 30, 40, 30. All right. If you've got another guess, you want to write it down, feel free. We're going to work it out here in a second. But we're going to play. We're going to play, which means I need 3 volunteers. 1, 2. Oh my gosh. We got more than 3. I've got 6 actually. All right. Here's what we're going to do. So come on up, all 6 of you. And we're going to combine forces here. Okay. So you 3 right over here. Okay. Or 3 of us right over here, whoever. And I need a recorder. Would you record for me? Okay, can you, on your paper, can you write down like A, B, and C, and just put tick marks for who wins? Okay. They'll tell you who wins. You just focus on counting them up for me. Okay. Can someone, Kelly, can you record for this group here? Okay. Same thing. Just they'll play the game. They'll tell you who wins. No, Kelly's gonna record. You 3 are gonna play. Now you gotta figure out who's A and B and C. Right?
Oh, we have to decide.
Yeah, you gotta decide who's A, B, and C. All right. So and then you're gonna play. Remember the rules are right here. If you need to look at the rules again. Remember, A wins if everybody's the same. C wins if everybody's different. B wins if 2 people are the same and 1 person's different. Okay? We're going to play 20 rounds. 20 rounds. All right? So make sure that your recorder can see you guys well, and make sure you're telling them. So after you do your round, tell your recorder what you're gonna what the result is. Okay? Who won? All right, go for it. You ready, Carly? Awesome. Thank you. Who won that? A, okay. You got it, Kelly?
What is that? Stop. Shoot. Wait. Rock, shoot, rock, shoot. Ooh. Rock, paper, scissors.
Rock,
Rock, paper, scissors. Rock, paper, scissors, shoot. Rock, paper, scissors, shoot. Rock, paper, scissors, shoot. Rock, paper, scissors, shoot.
You guys are getting quick.
Rock, paper, scissors, shoot. Scissors, shoot. Rock, paper, scissors, shoot. Rock, paper, scissors, shoot. How many rounds? Rock, paper, scissors, shoot. 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 Good job. Rock, paper, scissors, shoot. Rock, paper, scissors, shoot. Rock, paper, scissors, shoot. Rock, paper, scissors, shoot.
All right, are we at 20 yet? Can you count up and tell us where we're at? If you've got more than 20, that's okay. All right, so if you could total them up, Kelly, and tell me how many each got, that'd be awesome. You guys got into a rhythm there and you just kept going. All right, we got 20. Nice. All right, Sam.
Yeah, 3 left.
How many 8s? We were like all at the beginning, weren't they? 16. All right, let me know when you're ready for totals there, Carly. You got them? How many A's? 4. How many B's? 11. And C's? 5. Okay. So between these two experiments, we ended up with 8 A's, 27 B's, and 8 C's. So now there is such a thing called experimental probability. And we could talk about that really quickly in case that ever comes up. When you do experimental probability, you do an experiment like this and you add up and you find the probability based on an experiment, as opposed to theoretical probability, which would be like if we worked it out using mathematics. Experimentally, what would that be if we added all those up? We had a little more than 20 in one of our groups. 23 and 20, so 43. So I could grab a calculator if somebody hadn't taken mine. And I could do 8 over 43. And do you guys know what that would be as a percentage? About 18, but I'd say rounded to 19%. 27 divided by 43 is 63%. And 8 over 43 would also be 19%. Hey, somebody was pretty close there. And those don't add up to, that's kind of weird that those don't add up to 100, but that's because I rounded them. Someone was really close to that. Someone, oh no, maybe not. Or this one was the closest, the 20, 50, 30, I think. Pretty good. All right, now, so now I want you, this is the big question for the day, guys. And once we're done with this, we'll be done, okay? So I need you to talk it over with somebody who's sitting near you, and our goal is to come up with a theoretical probability for this. Let's all agree on how many different ways there are to do this, okay? So you got 3 people, right, that are all going to make their choice between rock, paper, or scissors. How many options does the first person have? 3. How many options does the second person have? Same 3 options. And how many options does the third person have? And 3 times 3 times 3 is 27. So when we do our theoretical probabilities, they're all going to be over 27. Your goal right now with somebody that's sitting near you, could you please discuss and figure out what numbers are going to go on the tops of each of these fractions? Okay, I'm going to give you about 5-10 minutes to discuss, and then we'll wrap it all up in a little bit. Okay, ready, set, go. All right, so we've got some ideas here. I heard 6 for B. Do you want to tell me your thought process? Oh, you counted them up, so you kind of listed them out. That's a great strategy. Well, let's start with A. What did you guys come up with for A? How many different ways are there to do rock, paper, scissors where all 3 people match? What do you think? There's 3, right? It's either rock, 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 paper, 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 or scissors, 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 right? That's the only way it can happen. So A is definitely 3 out of 27. I think everybody in the room got that. So somebody in the room, do you mind if I see your name? I'm looking at you now. Everybody knows it's you anyway. I'm glad. Jack did a really interesting thing with this. We kind of call coding, where you take kind of a complicated problem and you turn it into a simpler one. And so Jack's problem was, instead of playing rock, paper, scissors, I'm going to make a 3-digit number. And for each of my digits, I can use the numbers 1, 2, or 3. So when Jack thought through these 3, 1, 1, 1, 2, 2, 2, 3, 3, 3. And you can count them up nice and easy that way. That's a powerful tool when you're dealing with difficult math problems like that. I thought that was really cool. All right. Does anybody want to talk to me about B or C? Which one do you want to talk about, Alex? B. Okay.
I unintentionally kind of the same thing as Jack, where I just automatically put all.
Cool. All right. I wasn't quick enough to follow along with you there, but you were basically working through and you came up with 15. Okay. Hang on just a second. Did anybody come up with anything different for B? What did you guys come up with? You got 6 out of 27 for B. So we got a little question here. 15 over 27, 6 over 27. Anybody come up with something different for B? You got 18. Okay. I'll tell you what, why don't we talk about C first? Because at the end of the day, one of these people has to win, right? So whatever the number is on the top for these three things, they got to add up to 27, right? So if we can figure out what C is, like if 15 is right, then it's 3 and 15 is what? That's 18, and then we would need another 9 to get up to 27. So C would have to be 9. But let's talk about C. Let's see if we can think through C, because I think C is easier to think through than B is. Anybody got an answer for C that they think is going to work? Did you do it by listing? What'd you come up with listing?
Oh, I just put, I just used A and B to get.
Okay. Did anybody work C out kind of on its own? What did you come up with, Russell? You got 6 by listing them? Okay. Anybody else come up with 6? C was the one where everybody had to do something different. Someone help me out with this, okay? Can I get, guys, pay attention, please. We're almost done here. I want to talk about C in terms of decision making. There's 3 people playing, so 3 people got to make a decision. Let's make a decision so that person C wins. And person C can only win if everybody's got a different one, right? So let's say the first person is going to choose theirs. How many options do they have? They have 3. Second person is going to choose theirs, but it's got to be something different from what the first person picks. So how many options do they have? They have 2 options. Third person is going to pick theirs, but it's got to be different from both of the original ones. How many options do they have? There's only 1 left, right? No matter what the first 2 people pick, there's only 1 choice for the third person. So the total number of ways that C can win is 6. 6 is right. So this does end up being 6 over 27. And since this was 3 over 27, then this must be 18 over 27. And I'm trying to think of a way that we can do something like this to come up with this. I don't know 100% if this is going to work, but I'm going to. You kind of wrote out a list, and that's great until we end up having like 10 people play in this game. Right? So so B wins if 2 people have the same thing, right? But the third person has something different. So I'm going to make 3 decisions. See if you can follow me on this. I'm not 100% this is going to work. So here you go, mathematics in action. I'm going to make 3 decisions here, but they're going to be different types of decisions. Check this out. See if this works. Can you pay attention, please? Yep. All right. My first choice is going to be what's going to be the play that the 2 people match. Like, is it going to be rocks or is it going to be paper? Or is it going to be scissors? So this is going to be the play that my 2 matching people do. How many options do I have to choose for that? I got 3 options to choose for that. All right, so now I know that, for example, there's 2 scissors. Now my second choice is going to be what's going to be the third one that is different from those 2 matching ones. How many options do I have for that? 2, because I'm already using up one of them here. Can't be the same as this. So now I know, for example, I've got 2 scissors and a paper, but I don't know who has what. So my third choice is going to be, my third decision is going to be who are going to be the 2 people that match. And instead of asking that question, I think it would be easier to ask the question, who's the person that doesn't match? Because that's basically the same thing, right? If you 3 were playing and I said you didn't match, then obviously you 2 did, right? So how many options do I have to choose who is not going to have the matching one? I'd say I have 3, right? I've got 3 players. Either you're not matching or you're not matching or you're not matching. And if I multiply those together, what do I get? 18. That works out that way too. Hey, it worked out. I'm so glad that worked out. All right. Probability stuff we're gonna practice more in the second semester to get you guys ready for big tests that are gonna be coming up in the spring. But that's it for today. You guys did awesome. All right, let me set